Hello friends, in this video we are going to look at Java Iterator, and we will use this iterator to remove a collection entry while we are iterating the collection. So iterator is simply a reference over a collection element. So this reference will move forward when we are iterating it. So the Java Iterator, the iterator is a reference over a collection, referring its element one by one while we are iterating it. It is useful to iterate over a collection and retrieve values from it. So the for each loop will do that. The iterator also will do the same job. But unlike for each loop, the iterator can remove element from the collection. However, we cannot add elements using the iterator. So Java for each loop is read-only. You cannot add or remove element while you are iterating the collection. But when you use iterator, you can actually remove a collection entry. You cannot add an entry to the collection. Java Iterator is a forward-only cursor. This means the cursor will iterate the element in forward direction. We cannot iterate it in a backward direction. For example, you will start an element from head and move towards a tail. We can start anywhere, however, but we should move in the forward direction. So once an element is visited by the iterator, we cannot get back to that element because backward iteration is not possible. Let us look at iterating the element through Foreach. Here, the Foreach construct iterates over the fruits collection. This is highlighted in green, and you can assume this fruit collection can be any Java collection which supports iterator. So far we have discussed the array list as well as linked list. So both these data structure supports iterator. So we can assume fruits as one of that collection and it stores a string. The collection contains a string, so that's what I mean. So during each iteration, we will get an element in a string. So if you look at this for each structure, that means the syntax is here for, but it's known as a for each construct, and it iterates over the fruit, and this fruit collection is a collection of string. On each iteration, it will retrieve an element, which means it will retrieve a string, and that string is stored in a variable. So this variable is available inside the loop. So this is highlighted in yellow here. So we are iterating over the fruit collection, marked as green, and in each iteration we will retrieve an element. Since the fruit collection is a collection of string, on each iteration we will get a string. So that is marked here as yellow. So the retrieved element is stored in a reference called fruit. So this the fruit reference is available inside this for loop. So inside the for loop, what we are doing, we are checking whether the retrieved fruit is equivalent to banana. So if it is banana, then we are removing that fruit from the collection of fruit. So after the iteration is over, the aim is the fruits collection should not contain the fruit banana. But what happens, here Java throws concurrent modification exception. This happens when the loop tries to retrieve the next element after the modification. What this means, the removal of fruit succeed here, but when it tries to iterate for the next element, when it tries to retrieve element for the next iteration, that time the error is thrown. So that time Java knows that somebody modified this collection, so it throws that exception. Simply, in for each loop, you should not alter the underlying data structure. So for each is read only. That means once you come out of the for each loop, you can actually perform any alteration to the underlying data structure. Means you can add element or remove element. But inside the loop, once you started the iteration using the for each, the collection becomes read only, and you cannot make any structural modification while you are iterating the elements. Simply for each is read only. But at times we may want to remove the element during the iteration itself, right? So here if you see, the developer intention is not wrong, so it's absolutely right. The person want to iterate over the element and you want to remove all the fruits named banana in this collection. So now the iterator comes into picture. So here the title is saying for each loop iterator. This is actually a slide for iterator. Let us say we have an array list of 6 elements, just for a demonstration purpose. Since the array list is packed continuously, here it is shown as our elements are packed together. And the iterator is pointing at the first element. So in the underlying collection, whether it is an array list or a linked list, you can make a call to iterator method, and that method will return an iterator to you. So after returning the iterator points at very first element in the collection. The hasNext method call tells this iterator is pointing to a valid element. So here in our case, the iterator is pointing to a valid element 100. The method name may be confusing for some people. They may think that hasNext means it will check whether there is any element next to the current element. That means here 101 is there, so the hasNext will return true. It's not like that. So it is like the element is pointing to the valid location at this moment. So if that's the case, then hasNext will return true. When we make a call to next method, two action takes place. The iterator retrieves the element from its current position. If you look at the picture, at present the iterator is pointing at a first element. So this first action is retrieving that element, that means 100 is retrieved. And the next action is it moves to the next element in the collection. Here in our case, since we are talking about Arraylist, it moves to the next element in the Arraylist. So that's why the hasNext method will tell whether the call to next method will succeed or not. So you can read it like that. So the hasNext method, it returns true because we are pointing at a valid element and the element is 100. So that's why it returns true. When we make a call to next, it retrieves the element at current location and the cursor pointer advances to the next element in the array. Now, if you make a call to hasNext once again, it will return a true because it is pointing to a valid element. And when you make a call to next, it retrieves element 101 and cursor advances to the next location. hasNext is true, next will return 1 or 2, and cursor moves towards left. hasNext is true, next will return 1 or 3, and cursor moves to 1 or 4. hasNext is true, next will return 1 or 4, and cursor moves towards right. So at present we are pointing at element 105. Now if you make a call to hasNext, it still returns true. So this is where the confusion begins. So some people think that there is no next element, so hasNext should return false, but it will return true here. Why? Because it checks the element at current cursor position. So we have a valid array element at current cursor position. So if you make a call to next, it is absolutely valid. So hasNext tells, yeah, we have you can make a call to next element. So it returns true. When you make a call to next, it returns 105, and cursor moves to next location. Once it moves to next location, the hasNext becomes false. So since hasNext becomes false, we should come out of the iteration. Making a call to next is invalid at this moment. Okay, now let us go to Eclipse Demo. So in this demo, we are going to explore the iterator. So in our first run, we are going to add element to the array list. After that, we will run and check the elements are added properly. First, we need to place the required packages. Arraylist, this is the structure we are going to work, and then Iterator, this is for iterating over the array list. So first we will include these two packages. Next we create array list. Here if you see in the right hand side, we are creating an array list with a new keyword. In the right hand side, we are referring that with the reference fruits, and it is a strongly typed array list. That means the fruits will accept only string. Alright, after this we added elements to that array list, and we will place this sample. Now we will just debug and see. So first we are creating the array list. Now we will add element one by one, and you can watch here. So the elements are gets added. So that's all in this test run. Now we will move to our second phase. Here what we are doing, we are using a for each loop. So we are iterating over the fruit we created here. We added element. Now we are iterating over that fruit. Since fruit stores a string, in each iteration we are taking one string and we are storing that in a reference called fruit. Inside the loop, if you see, we are referring this a fruit. So first we are printing the fruit here, then after that we are comparing whether that fruit is equivalent to banana. So if it is the case, we are removing it. So now we will use a breakpoint here in the for. Now we will iterate it. So if you see, first time we will get apple. So you can see here. So it will print that it will print apple. So this condition will fail. Next time it will return orange. So no modification to the underlying Arraylist structure. Now we are retrieving banana, and that will be stored in string. It get printed here using this system.out statement. Now since the fruit is equivalent to banana, we will enter inside this if construct. Now we are making a structural modification. If you see here, it is banana. The banana will get removed. Now our iterator is iterating over this collection. So when it tries to retrieve next element, it knows that this structure is modified. So it raises the exception. If you see, now it states that java.util concurrent modification exception. If you look at where the exception is raised, it is raised in the for structure, not the remove. So remove is allowed. We already saw that the banana got removed. So during the next iteration, Java thrown this error concurrent modification exception. Now we will comment this piece of code. Okay, now we will understand how the iterator works. So what we are doing, first we are writing a function. The function name is iterate_list. So we are taking the array list as a parameter. Then here from the fruits, whatever is passed in, we are making call to iterator. So this iterator method will return an iterator. So here we specified it's an iterator over a string. Alright. Next what we are doing, we are making call to hasNext. Then we are making call to next. So this next will return the element. So here the element type is a string. So we are storing that in the string reference. After that we are printing that as string. So we are iterating like this. The hasNext will return false when iterator get past the last element. So we will come out. Alright, now since it's a method, we are placing it after the main. So the method is ready. Now we have to make a call to this method. So if you see, we are calling this method and we are passing the fruits. In the main, we constructed the fruits and added the elements. Next, we have written a function iterate list. So the iterate list accepts an array list of string. So we are passing that fruits now. So this fruits is now array list of string. Each string represents a fruit. Alright, now we will call this function and explore. So this is our third test run. This is just to understand how the iterator works. So let me step in. So now hasNext will return true. The next will return the fruit. So if you see, it returned apple. Next time it returns the second fruit, orange. So likewise we continue. You can watch here whatever is retrieved. So 2 orange. Now we are at our last location. So we retrieved these two. At present now we are here. So hasNext returned banana. Now we are hasNext returned true. Now the next call will return, the call to next will return the current fruit banana, and the pointer advances to next location. So now we are printing whatever is returned by the next. Since it's a two-phase action, it returned the banana fruit. Now it moved to the next location. So at this stage, the cursor pointer is not pointing to a valid location. But here what we are printing is whatever it retrieved in the first phase. That means it returned the string banana, then it moved to the location 10. And location 10 doesn't have any valid element. So we print that banana, and when we make a call to hasNext, it will return false. So we come out of this loop. So if you see, we retrieved all the fruits using the iterator. So previously we failed when we try to modify, right? When we try to modify the underlying structure. So the fruit.remove removed the element, but the next iteration failed. Now we will do the same using the Java Iterator. So this is our final test run. Here we are creating a function called iterate and remove. It accepts two parameters. One is our array list, like our previous version iterate list. Then it accepts one more parameter, fruit name. So this is the name we want to remove. So here we retrieve the iterator from the underlying collection. Then we are iterating over it. Here we are checking the fruit name with the retrieved element. So the retrieved element is here. So this is the retrieved element, and this is the fruit name which is coming as parameter. So when there is a match, we are removing that element from the collection. Next, we are making call to that iterate remove, our last version of the function. Here we are passing the fruit. Then we are passing a string stating that we want to remove apple from the collection. After that, we are iterating over the list for a printing purpose. Here in this iterator iterate list, we are actually iterating as well as we are printing. So this iterator just removes the element. Alright. Now we will make a call to both these functions. Now we will step in. So we get the iterator using fruits.iterator. The hasNext will return true since it is pointing to a valid location. The call to next will retrieve element apple, then advances the pointer to orange. Now at present we are here, but we already retrieved apple, that is stored here in a string. Now we are checking str, which is apple, with the incoming parameter, which is also apple. So we get inside and we remove the element. Now apple will get removed from here. So the next iterator is for orange. Orange will not get removed. Then banana, it will not get removed. Then once again apple. Sorry, I think I get lost. Okay, let me retrieve and check what is the current element. str is apple. Now this time we retrieved apple, and if we make a call to remove, it will remove the fruit apple. So likewise, if you see, there is one more apple that will also get removed. That's all. So this time if you see, the iteration succeeds. It doesn't complain that the structure is modified. So the iterator can remove element from the structure, underlying data structure, while we are in the iteration. So in the iteration itself you can make modification, but that modification should be a removing element. Next we are printing the fruit list. This time I don't want to step in, we will directly execute it. Now we will look at the output. If you see, in the very first time when we printed the list, it contains apple. There are 3 apples here, and our list, through using the list iterator, we removed all the apples here. So this is the purpose of iterator. So while you are iterating, you can remove the element, but when you are using the for each, so we commented out it, right? So when we are using the for each, you cannot remove it. So the remove will succeed, but the next iteration fails. But here, when you use the iterator, we can successfully remove the element and we can advance to the next element. So the iteration continues here. That's all in this video. Thank you for watching, and if you like the channel, subscribe it. Bye.